Let's take a look at question number 5. It says your principal surprises you by buying your class a turtle. He brings the turtle to your class along with a sheet from the pet store titled Turtle Tank Rules. And the rules state, tank walls must be at least 1 foot tall so the turtle can't climb out. And 2, there must be at least 400 square inches of floor space for the turtle to walk around on. Your teacher says the volume of the tank must be smaller than 5,000 cubic inches so it doesn't take up too much room in the classroom. Give the dimensions of a tank that would work for your new turtle. Use words and numbers to explain how your tank satisfies the turtle tank rules and your teacher's requirement. And then it gives us a formula to help us remember that the volume of a rectangular prism equals length times width times height. Okay, so fine, we got a class pet, we got a turtle, so now we need a tank the turtle can call home. We have options here. We just need to make sure that the tank we designed follows a few simple rules. The rules are that the walls must be at least 1 foot tall so the turtle can't climb out. It's a good rule. Second one is there must be at least 400 square inches of floor space for the turtle to walk around on. And the teacher says the volume of the tank must be smaller than 5,000 cubic inches. So we have 3 criteria that our tank must meet. So let's draw our tank. So we have a rectangular prism, so we have the width, we have the length, and we have the height. So our tank has to meet these criteria. The volume, the height, times the width times the length has to be less than 5,000 cubic inches. So height times width times length must be less than 5,000. And it also says there needs to be at least 400 square inches of floor space for the turtle to walk around on. So the floor space, that's our width and that's our length. So the width times the length has to be at least 400 square inches. So it has to be equal or greater than 400 square inches. Okay, and then the walls must be at least 1 foot tall. So let's start with the width times the length. We'll design our floor first. So we have to have the width times the length has to be equal or greater than 400. So what 2 numbers can we multiply together that are equal or greater to 400? So let's decide to make the width 45 inches. And let's make the length 10. It's easy to multiply. 45 times 10 is 450. So 450 square inches of floor space for the turtle. That meets the requirement. It's greater than or equal to 400, so that's good. So the width, first we'll make the width 45 inches and we'll make the length 10 inches. And so now we need to determine what the height will be. So we have width times length. We have 45 times 10 equals 450 square inches of floor space. Now, the height times the width times the length has to be less than 5,000. So that means if the length, whatever the length is, multiplied by 450 has to be less than 5,000. So let's make our height, let's make it also 10. It's easy to multiply by 10. So we have 450, which is equal to the width times the length, and we multiply that by the height, which is 10. Then we have 4,500, which is less than the requirement of 5,000 cubic square inches. So we have 450 width times length. We multiply that by a height of 10. 450 times 10 is 4,500. So let's explain that using our words. So first, I chose a width of 45 times a length of 10 so that gives me 450 square inches of floor space for the turtle to walk around. That meets the requirement that it's at least 400 square inches. Then I chose a height of 10 and I calculated the volume. So it gave me the formula here. Volume of a rectangular prism is equal to the length times the width times the height. And so we know that the width times the height is 450. It's 45 times 10. And we multiply that by the height. We have 4,500. And that gives us our total volume, which meets the requirement that the volume, the teacher said the volume of the tank has to be smaller than 5,000 cubic inches. So we have 4,500 cubic inches. So first, we use numbers for the length times the width. Then we use the height of 10 and we calculated the volume. And so finally, we solved for the volume, height times width times length, that equals 4,500. And so we chose our final dimensions. And it met all of the requirements. The height is 10, width can be 45, and the length can be 10. And that's one option for creating a turtle tank that meets all of the rules. You might come up with a different option, but that's how we solve problem number 5.